Hi sir, I'm Ramanujan Barigala. Here I am giving physics demo. My topic is projectile motion. Yes, we know that motion is if the body's position is changes with respect to time, that is called in motion. Yeah, projectile motion is one kind of two-dimensional motion. Let us see what happens if a body is in projectile motion. Yeah, let us take what is projectile motion. If we throw any body with some angle to the horizontal, that is called projectile motion. In daily life examples, if you put some hole to the water vessel, the water will pour outside with some distance like this. So like this. This is called projectile motion. If an athlete throw a javelin, that is the path of the javelin traveling is called projectile motion. If we throw a stone with some angle, the path of the stone travels is projectile motion. If we fire a bullet from the gun, the bullet motion is called projectile motion. These are the examples in daily life. Let us see on which factors the range of projectile body depends and which path that projectile body takes, at which height it will move upward direction, and what time it will take to reach that height, and what time it will take to reach maximum range in horizontal direction. Let us see all the information. Yeah, let me take what is projectile motion. If we take two-dimensionally, say this is x and this is y. So projectile body, say the one stone is thrown with u velocity, it is moves like this and it reaches some height, and again it will start coming downward direction, right? Okay, yes. So first initially I have thrown this body with u velocity. We know that velocity is a vector quantity. We can resolve this vector into two components, two rectangular components. One is along x direction, that is u cos theta, if this projection angle is theta. This is along y direction, this component is u sin theta. Yes, we know that if a body is projected, it means it is under gravitational force. So when gravitational force is acting on that one, the only gravitational acceleration acts on the body. That means, so the gravitational acceleration is acting in the y direction only. So if you take along the upward direction and downward direction, the gravitational force is always downward direction. So acceleration also in this direction. So acceleration upward direction, force is downward only. So take g as positive downward direction, upward minus g. That means it is direction representing. Yes. See, its horizontal component never changes. Okay, na? The acceleration along the horizontal, that is along the x direction, is 0 because velocity is not changing. That means change in velocity is 0 by time gives 0. Along the y direction, the acceleration is changing. So keep on decreasing up to certain height. There it will become 0 in the y directional. These two x and y axis motions are independent motions. So this is become the velocity along y direction. So this is initial velocity, the final velocity if you take here along the y direction. So Vy equal to 0 at some point, that is called maximum height we say. After that it starts coming downward direction. So here only horizontal motion, horizontal velocity acting, that is u Vx say Vx is equal to u sin theta because u cos theta, because the velocity component in horizontal does not changes, right? So after that again the vertical component of velocity only changes and reaches to same level of the ground, and if it is projected from certain height again it will come down like this. Okay, let us see for this case. Okay, ground to ground. For this one, let us find what is the path it travels. What is this path? By looking we can say it is half circular path. Let us see, is it moving in the circular path or some other path? Let us see. Yeah, for this one I am taking along the x direction is traveling. So along the x direction, let us say it is moving with s velocity, s distance, that means displacement along x, that means here x is 1, here x is 2, x is 3, like this. So generally I am taking along the x direction, the displacement is x. We know that s equal to ut plus half at square. Okay, ut plus half at square. Yes, and s means x, that equal to u means u along the x direction, acceleration. Yes, x direction u cos theta into time. After say some time it has taken, so I am taking general time into t, plus we know that acceleration along x direction is 0, so half into 0 into t square. So something, this will become 0. So x is equal to u cos theta into t. So from this is displacement along the x direction. What is the displacement along the y direction after time t? That means same formula only we are using. Yes, s equal to uy after t plus half ay into t square. That means ay is upward direction, it is moving. So ay is minus g, and uy equal to, we know that u sin theta. So substitute along the y direction, say it has reached y, that means u sin theta into t minus 1 by 2 g, okay, g t square, right? So we are deriving the equation for finding the path at which path it is traveling, right? For denoting for getting that path, we must have the equation in terms of x and y, right? For example, y equal mx means this is the line which is passing through the origin, straight line passing through the origin. Why? How can we say this one? How could we say this one? Because y and x equation only. So for getting that kind of equation, let us substitute t value here. Then we will get the equation in terms of x and y. So from this we can write, t is equal to x by u cos theta, right? In the place of t we can substitute that x by u cos theta. then when you substitute that one, you will get u into sin theta, that is x by u cos theta, minus g, that equal to, it will become x square, that u cos square, that will become, already 2 is there, 2u square cos square theta, u cos square theta. So from this we can write this one as u sin theta by u cos theta is equal to x into u tan theta, right? X into u into tan theta. So it is equation in terms of quadratic, that means x power is 2, that means it is quadratic equation. We know that the quadratic equation ax square plus bx, okay, this graph is like this, okay. Yeah, when you compare this one, the coefficient of x square is negative, that means this curve is on downward, yeah, it is downward direction, yeah, that means this quadratic equation denotes parabolic path. What is that? Parabolic path. That means the projected body travels in the parabolic path, right? So from this equation we could say that if any body is projected, it takes the trajectory of the path is parabolic, right? See, this is confirmed from this equation. Let us see what is the time takes to reach the body at maximum height. Okay, what is the time taken by the body to reach maximum height? So we know that to find that time, we know that v equal to u plus at. Okay, we want time from here to here. Say the acceleration is minus g, the vy final velocity at maximum height is 0, uy along the y direction velocity is u sin theta, this is ay, that is minus g. Let us substitute that one. Uy is u sin theta and minus g t, yeah. From this can we write t max, that means time taken for reach maximum height is u sin theta by g, right? U sin theta by g. So let us write this equation somewhere. The time taken t max tm is equal to u sin theta by g. Okay, let us write here. Okay, this is, yes. So it has taken u sin theta time. What about within the time, how much height it has reached along the y direction? Let us see that maximum height along the y direction. Now equation for maximum height along y direction, y axis. Okay, yeah, for that one, let us take that one, that height is, say, s is maximum height. In the place of s I am taking h max, okay, that is ut plus of at square I am using, right? So what is the initial velocity and what is the time we know, like this, tm I will write ay uy. So let us substitute all the values. U sin theta into u sin theta by g, right, minus of into g u sin theta by g whole square. Okay, so when you simplify this one, you will get u square sin square theta by g minus that is g by 2 u square sin square theta by g square. Okay, so if you cancel 1g here, you will get 2g. So from this 2g, if you take LCM and do simplifications, you will get u square sin square theta by 2g. This is the maximum height that reaches the projected body. So let us write the maximum height. H max is equal to u square sin square theta by 2g. Okay, this one completed. And let us take what is the time taken by the body to reach the maximum displacement along the x direction. The displacement along the x direction usually we call range. Okay, range. So what is the time taken by the body to reach maximum range? So time. So that means usually we call it time of flight. That means within the air it is there. So this is the total flight time. That is why now we are deriving the equation for time of flight. Time of flight. Right, time of flight. So we know that. Yes, time of flight. Yes, for this one, let us take what displacement formula. Displacement equal to ut plus of at square. Displacement along the y direction, x direction, right? So for this one, I am taking this y coordinate. Y displacement became 0 again. Here displacement along the y direction is 0. After certain time, it has again became displacement 0. Okay, so along the y direction displacement is 0 at the maximum range. So it is started with u sin theta, okay, along the y direction. And now we are finding TF, time of flight. Okay, this is y direction. Okay, no? We know that AY is minus theta, like that. Substitute all the values. UY is u sin theta, and T is, we need to find time of flight, right? Minus G by 2, time of flight we need to find. Okay, so from this we can write this one u sin theta into TF G by 2 TF square. So both sides one T will get cancelled. So time of flight is equal to 2u sin theta by G. Yeah, that means twice the time of half of the height. That means u sin theta, the time will taken by the maximum height is u sin theta. Again from here also, from here onwards, here it will take same time. That is why time of flight is twice the time taken by the maximum height, right? So this is time of flight. Time of flight is equal to twice the time of max, 2u sin theta by G, right? Yeah. So let us derive the equation for what is the displacement along the x direction. Okay, what is the displacement along the x direction? We know that displacement is, okay, displacement is along the x direction. Displacement is, yeah, let us say this is simply range along x direction, x axis. So range is nothing but displacement. The displacement is velocity into time. Okay, What is velocity? U x. What is time? The time taken by this one is time of flight. We know that along x direction the velocity is u cos theta. The time of flight is twice the time of max, right, by g. So if you simplify this one, you will get u square sin 2 theta by g. This is the range that covered by the body, which is projected with theta angle with u velocity. So we can write the range is equal to u square sin 2 theta by g. These are the equations that we get when a body is projected with u velocity with theta angle, right? This is about projectile motion from ground to ground. Pause here. So far we have discussed what is projectile motion, what is the path it takes, and what is the time taken for the body to reach maximum height, what is the maximum height, and time taken for the body to reach along the x direction, that is time of flight, the range we have discussed. So let us solve one problem in projectile motion. Let us see one problem. If a body is projected, if a body is projected with complementary projection angles, then the ranges are equal. So let us prove that one. We know that complementary angles means sum of the angles is 90. So let us take two angles. I am taking two angles which is 45 plus alpha, right? 45 minus alpha. We will get this will get cancelled. This will you will get 90 degrees. So 45 plus alpha, 45 minus alpha. Both angles are, say this is the theta 1 angle, this is the theta 2 angle. Sum of theta 1 plus theta 2 is equal to 90 degrees. So theta 1, theta 2 are complementary angles. Let us see, if we project a body with complementary angles, they will cover same range along the x direction. Let us prove that one. We know that. What is the range formula for theta 1? Take 45 plus alpha. For theta 2, this is 45 minus alpha. So we know that range is u square sin 2 theta by g. Range is u square sin 2 theta by g. Let us substitute the angles. Both are projected with same initial velocity only. We know that g is the constant everywhere. So the projected velocity is same for both. The projecting angles are different. So they are complementary angles. Let us substitute their angles. U square equal to sin 2 of 45 plus alpha by g, and here u square sin 2 into 45 minus alpha by g, right? So from this we can simplify this one. Sin 2 into 45, 90 degrees, 2 into alpha, 2 alpha degrees by g. This is u square, same sin of 90 degrees minus 2 alpha by g. Let us simplify this one. Sin 90 plus theta, we know that is cos theta, right? So u square cos 2 alpha by g. Here sin 90 minus theta also cos theta, right? U square cos 2 alpha by g. This is the range of theta 2. This is the range of theta 1. So any difference in ranges? U square is there, cos 2 alpha is there, cos 2 alpha by g. So everything is same. That means if the projecting angles are complementary angles, they will cover same range along the horizontal direction. This is one problem we solved in projectile motion. Yes, this is about my demo for projectile motion. Thank you.